now we have two young EPFL students, EPFL stars. And this is a special series of talks which we are offering for students from not only from EPFL but also from any other institution, or even if you are a freelancer, you can also come to us and present it. And these two students I met first time on Applied Data Analysis course. It's given by Robert West, who is going to talk next month. And the project which we are presenting is a group project which is assigned to each group of students. This is something what I really like here in Switzerland and specifically on the EPFL, that they had to really put effort to not only to pass just exam, but to develop something unique. And those students are not just students, I found them quite ambitious people, and I will just present you. So the Jean-Baptiste, Bastide Cordonnier, he actually, you can check his LinkedIn also, he already did like 2 times internship in Amazon. And also he worked for 1 year or 6 months in Carnegie Mellon University for student exchange. And also he's a teaching assistant at EPFL, so he's already teaching other students and things which he's like functional programming, information theory, parallelism and concurrency. So quite a lot of things, quite a lot of quite impressive resume just for a student. And Brune, she's also extremely talented, and especially gonna to see that she's not shy and really easy to speak, and she's speaking for more than 1,000 students because she's a student representative at EPFL, and first year selected, yes? Yes, so really like try to fight for student rights, for student quality of our education. And beside this, of course, she's a software developer and she likes to program in multiple languages, Python, C, Scala, Java, MATLAB. And she's even a student champion for SIGPA to promote this awareness, brand awareness at EPFL. So please.
Hi, can you hear me? Yeah. So, as Pavel already told you, we're Jean-Baptiste and Brune, and we're here today to present a project that we made in applied data analysis. So, the course was given by Bob West, and we were asked to work on data science for social good. So, the first step of a machine learning project is to collect data and understand data. We decided to focus on avalanches, and as most of the accidents are due to people's bad decisions, we believe that with machine learning technique, we can raise awareness on alpinism-related casualties. So we started by scraping data from the Swiss Institute for Snow and Avalanche Studies. So we scraped data for data that was worth 20 years of data. So we have gathered 2 data sets. The first one gathers all the accidents that happened over the last 20 years in Switzerland. And the second one retrieves all the information that you can see on images that represent maps. So here is a sample of the maps that we gathered. And you can observe that we have different kinds of maps. We have snow depth, fresh snow, and danger levels. You can also observe that we have different color key, and the size of the images changes over time. So that was the first challenge for us. So, as I said, we retrieved 20 years worth of data. So that's around 10,000 of images. So here are 2 samples of the maps that we gathered, and I'm just going to explain how we automated the process of retrieving all the information on those images. So first, we applied a mask, so we clipped the images in order to focus on the relevant information, which is here, in our case, Switzerland. You can also observe several points that we have on the mask, which are landmarks, and I'm going to talk about this later. So with those masks, we could just focus and remove all the noise around Switzerland. Then we projected all the colors onto one color key, because I told you just earlier that we have different colors over different images, and we removed all the grays. So that's removing the low variance pixels colors. Then we applied the smoothing algorithm to just obtain the region here. We could obtain the region contours, which we could further project onto real maps. And remember those landmarks that I talked about earlier? Here, they are very useful. So, our solution here to raise people awareness was to provide an interactive tool for people to play around with and to find patterns. So you can see here that we have several elements, and this one, the central one, represents a mountain. We have different elevation here and some aspect of the mountain that you can select. For example, if I want to ski on the east aspect of a mountain, I can just select the aspect. And you can see that we have histograms that move all around here. Now, if I want to ski, for example, go backcountry touring in the summer, I can select some month. And here I see that actually if I want, well, I don't want to be exposed to some risk, but I'll be more exposed to risk of avalanche casualties if I climb high. So here you can see 4,000 elevation is a huge risk. And if I go backcountry touring, I can see that actually 13 casualties happened. Well, we had 13 deaths here. Now I can also select some casualty that happened over the last 20 years, and the maps that we gathered here just are information that you can see here, and you have access to 10 days before and 3 days after each casualty that happened, and you can observe the amount of snow, the danger level that was announced. So you can just find patterns of different avalanche casualties that happened in the history, and you can learn from it in order to avoid risk. So, the main technologies that we used for that project was Python, OpenCV, and D3JS for visualization. As I told you, we retrieved information from the Swiss Institute for Snow and Avalanche Studies, and we encourage you to go check their website because you can see the raw data. And as a future work, we think that it could be very interesting to retrieve data for, well, weather data of the last 20 years in order to be able to forecast the future avalanches that can happen. So we encourage you to go check our website if you want to go ski in the next days. And thank you all for your attention. If you have questions. Sure.
Does it work?
It's awesome.
Just one question. I think you didn't use the slope angle, right? Right? Okay.
Yes.
Is it something that that would be awesome to see? Did you? I know it's not in SLF. Was it difficult to extract, or I know it's on map admin.
The slope angle.
The slope angle.
Yeah. Yes. So yeah, it's a great feature for machine learning, this slope angle normally to predict avalanches, and it's actually not so hard because the location of the casualty are very well marked, and we could just do like a plan estimation and find the slope. So yeah, that would be also.
I think it's the major thing to predict avalanches.
One of the major features.
Yeah, indeed.
So in your data you use lots of additional numbers. I can imagine that you get, because you have more pieces are open or more places are open during certain times of the year, you have more deaths just generally. So that will change with altitude. So did you account for these kind of biases?
Yeah, there are many biases, especially for like the data level. When the forecast of the danger are out, then people will go less if it's like danger 4, and that's one of the main one. The one you saw also for summer was a strong one. So we try to do some statistics to balance the populations. When we are doing some statistical tests, then we would like do a matching between the population and match on the features that we have. So we cannot really know everything about the decision process that people are taking to go out or not, but we can assume that if it's like a big group of 10 people that are going out at 4,000 meters, they are more like alpinists and more advanced. So when we do the statistics, then we downsample and only select the meaningful pairing. It makes sense? Or? So we can discuss.
Last question before the break. I would have a question. Do you plan to make an app for the phone?
Do you plan to? So for now it's a website, so you can all browse to it, and yeah, no, it's not in the plan. I mean, the next step would be more to try to do forecasting. It's actually a hard problem that has been studied a lot in statistics, all these natural casualties and things like this, like landslides. So that would be an interesting problem to tackle. Yeah.